Friends, welcome to s.mathguru classes. Our main discussion is Jacobians. Jacobians we solve some problems and also we solve some problems about functionally related, and functionally related means if Jacobian is 0 then this is functionally related. Now we consider the remaining problems. Show that the function u equal to x plus y plus z, v equal to x square plus y square plus z square minus 2xy minus 2yz minus 2zx n w equal to x cube plus y cube plus z cube minus 3xyz are functionally related. Find the relation between them. If they are functionally related, then we have to find relation between them. Show that given, that means this will be functionally related. That means Jacobian is 0. We have to find. So solution is that u equal to given x plus y plus z, del u del x of x plus y plus z, this is 1 plus 0 plus 0, this is 1. We differentiate partially with respect to x, y and z constant, this will be 0. Del u del y, del y x plus y plus z, this is 0 plus 1 plus 0, this is 1. Del u del z z x plus y plus z, and this will be 0 plus 0 plus 1, this is 1. So we get del u del x, del u del y, del u del z. Now we consider v equal to given x square plus y square plus z square minus 2xy minus 2yz minus 2zx. We find del v del x. This is del x of x square plus y square plus z square minus 2xy minus 2yz minus 2zx. And this will be twice x plus 0 plus 0 minus 2y minus 0 minus 2z. This is twice x minus 2y minus 2z. We get this one. Now del v del y, del y, this is x square plus y square plus z square minus 2xy minus 2yz minus 2zx, and this equal to 0 plus 2y plus 0 minus twice x minus 2z minus 0, and this will be 2y minus 2x minus 2z. We get this. The last one is del v del z, del z x square plus y square plus z square minus 2xy minus 2yz minus 2zx, and this equal to 0 plus 0 plus 2z minus 0 minus 2y minus 2x, and this is 2z minus 2y minus 2x, this one. So these are v, we differentiate partially with respect to x, y, z. Now w we consider. W equal to given x cube plus y cube plus z cube minus 3xyz. Del w del x, this equal to del x, x cube plus y cube plus z cube minus 3xyz, and this is 3x square plus 0 minus 3yz, and this equal to 3x square minus 3yz. We get this. And del w del y, del y x cube plus y cube plus z cube minus 3xyz, and this will be 0 plus 3y square plus 0 minus 3xz. we differentiating partially with respect to y, x and z constant, this will be 0, and this will be 3y square minus 3xz, and del w del z, this is del z x cube plus y cube plus z cube minus 3xyz, and this equal to 0 plus 3z square minus 3xy, and this is 3z square minus 3xy. We get these are the values of del w del x, del w del y, del w del z. Now our requirement Jacobian. Now del u v w del x y z, what we get? This will be by definition of Jacobian del u del x, del u del y, del u del z, del v del x, del v del y, del v del z, del w del x, del w del y, del w del z, this one. And this equal to, we putting the values, and these are 1 1 1, first we get 1 1 1, and del v del x, we get del v del x, we get 2x 2y 2z, we taking this is 2x minus 2y minus 2z, and del v del y 2y minus 2x minus 2z, del v del z 2z minus 2y minus twice x, we get this, and v is over. Next is consider w, this is 3x square minus 3xz, and this is 3x square minus 3yz, 3yz, and 3y square minus 3xz, 3z square minus 3xy. These are the values of del u del x, del u del y. These are just putting the values, we get this one. Now if we subtract these two columns, this minus this minus this, we get 2 zeros. If we taking to find 2 zeros, then answer will be shortcut we get. So just we write C1 tends to C1 minus C2, C2 tends to C2 minus C3. So this minus this, we get 1 minus 1, next 2x minus 2y minus 2z minus 2y plus 2x plus 2z. Just subtract this, and this minus this, 3x square minus 3yz minus 3y square plus 3xz, and again this minus this, 1 minus 1, this minus this, 2y minus 2x minus 2z minus 2z plus 2y plus twice x, and here also this minus this, we get 3y square minus 3xz minus 3z square plus 3xy, and this is 1 2z minus 2y minus twice x by 3z square minus 3xy, this one. Now this will be 2 to 1 cancel 0, and here we get 2z cancel, we get 4x minus 4y, and this is 3x square minus 3yz minus 3y square plus 3xz, and this is 0, and we get twice x cancel. This is 4y minus 4z, 2z 4z, and 3y square plus 3xz minus 3z square plus 3xy, and this is remain same 1, 2z minus 2y minus 2x, and this is 3z square minus 3xy. We get this, and from this we taking 4 common. So this is just we expand this. If we taking 4 common, this, if we just expand this is 0 minus 0, this is plus 1, just taking 1. If we taking 1, then this column cancel, this row cancel, this into this minus this into this. So we get 4x minus 4y into 3y square minus 3xz minus 3z square plus 3xy, and this into this minus 4y minus 4z into 3x square minus 3yz minus 3y square plus 3xz. We get this one. And from this taking 3 common, from this 4 common, 4 into 3, then we get x minus y. This is y square minus xz minus z square plus xy. And here also taking 4 common, and here 3 common, 4 into 3, y minus z, x square minus yz minus y square plus xz. We get this one. Now this and this common, 12 is common, and multiplying all of this by x, y square, x square z, x z square, x square y, and multiplying by minus y cube plus xyz and plus yz square minus xy square. And this 12 is common, we multiply all of this by y, but in front of this minus sign, then this will be minus xy square plus y square z, and this is plus y cube minus xyz, and multiplying by minus z, minus plus z, that means plus z x square and minus yz square minus y square z plus x z square. We get this one. Directly I have written this. Now x y square, these two are cancel. X square z, this is minus and plus cancel. X z square, this and last one cancel. Y cube minus and plus cancel. X y z, these two are cancel. Y z square, this and this cancel, and y square z, these two are cancel, and x this will be x, this 2 x square y cancel, and this is 12 into 0, this is 0, we get the 0. Answer 0 means they are functionally related, so that u, v, w are functionally related. Therefore u, v, w are functionally related. We get this, they are functionally related. Now what is the relation between them? We have to find a relation. Find second part. Find the relation between them. Now W equal to x cube plus y cube plus z cube minus 3xyz. And this is a direct formula, we know. This is x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. This is a direct formula. Now this value is u. We know this is u. And this will be x square plus y square plus z square. But for writing v, this must be minus 2xy minus 2yz minus 2zx. So we write this is 2xy minus 2yz minus 2zx. Now we adding xy plus yz plus zx. We adding this. We write minus 2xy then plus xy. Ultimately this and minus xy. This is minus 2yz plus yz. This is minus yz. Ultimately we get this. And this is u, and this whole, this is v. V we get, and this is xy, yz, zx. We get this. Now this will be uv plus u into xy, yz, zx. Now uv, u, and we taking here 4 and multiplying all the terms by 4. 4xy, 4yz, 4zx. Taking 4 and multiplying all of this by 4. If we taking 4 common, 4 cancel, we get this one. Now uv, u by 4, and this can be written as x square plus y square plus z square minus x square plus y square plus z square, x square plus y square plus z square, and plus 2xy plus 2yz plus 2zx minus x square plus y square plus z square minus 2xy minus 2yz minus 2zx. We write this. Now if we remove the bracket minus x square minus y square minus z square, that means this 3 will be cancelled. And this will be plus 2xy plus 2yz plus 2zx. This will be 4xy 4yz. We get this term. We can write this. Now this is uv, w equal to uv, u by 4, and this whole we can write x plus y plus z whole square. And this whole, this is our v. This is v. So what we get, w equal to uv plus u by 4, and this is nothing but our u. This is u. U square minus v. We get this. And this is w equal to uv plus u cube by 4 minus uv by 4. If we taking LCM of this, w equal to 4 uv minus uv, 3 by 4 uv plus u cube by 4. So multiplying both sides by 4, then 4w equal to 3 uv plus u cube, or we can write 4w equal to u cube plus 3 uv. So this is the required relation between them. This is the required relation between them. This is the required relation between u, v and w. So this is the complete solution. Very easy solution. Next we consider another masti problem. Verify whether the following functions are functionally dependent. If so, find the relation between them. U equal to given x plus y by 1 minus xy, v equal to tan inverse x plus tan inverse y. Now solution, u equal to given x plus y by 1 minus xy, del u del x, del x, x plus y by 1 minus xy. And this is quotient rule, division formula, denominator whole square, denominator del x of numerator minus numerator del x of denominator. We get this. And denominator remains same. This is 1 minus xy and this is 1 plus 0. X plus y, 0 minus y, because we differentiate partially with respect to x, y is constant, and this will be 1 minus xy whole square, 1 minus xy plus minus plus xy and plus y square. So ultimately we get 1 plus y square by 1 minus xy whole square. We get del u del x. Next del u del y. Same process. Del u del y, del y, x plus y, 1 minus xy. Again using division formula, 1 minus xy whole square, 1 minus xy, del y, x plus y, minus x plus y, del y, 1 minus xy. And this will be 1 minus xy whole square, 1 minus xy, this is 0 plus 1, x plus y, this is 0 minus x. We get this 0 minus x. Next this will be 1 minus xy whole square, 1 minus xy plus x square plus xy, and this is 1 plus x square by 1 minus xy whole square. We get this is del u del y, del u del y. Next v equal to tan inverse x plus tan inverse y. Del v del x, this is del x of tan inverse x, del x of tan inverse y, and this is 1 by 1 plus x square, this one 0, and this is 1 by 1 plus x square you get. Next del v del y, del y, tan inverse x plus tan inverse y, 0 plus 1 by 1 plus y square, this is 1 by 1 plus y square. We get this one. Now our requirement, now del uv del xy, this equal to del u del x, del u del y, del v del x, del v del y. We get this. Now putting the values, del u del x, we get 1 plus y square by 1 minus xy whole square. Del u del y, we get 1 plus x square by 1 minus xy whole square, and del v del x we get 1 by 1 plus x square. This is 1 by 1 plus y square. Now expand this into this minus this into this. So this will be 1 plus y square by 1 minus xy whole square into 1 by 1 plus y square minus 1 by 1 plus x square into 1 plus x square by 1 minus xy whole square, and ultimately these two will be cancelled. These two will be cancelled. We get 1 by 1 minus xy whole square minus 1 by 1 minus xy whole square, and this equal to 0. Therefore, UV are functionally related. So that the functions are functionally dependent. That means they are functionally related. For what we get, they are functionally dependent because Jacobian is 0. Next, what is the relation between them? Now we have to find relation. Now second part we consider V equal to given tan inverse x plus tan inverse y. This implies tan inverse x plus tan inverse y, we know direct formula. Tan inverse x plus y by 1 minus xy, we know this formula. And this tan inverse, so tan v equal to x plus y by 1 minus xy, and tan v equal to, this is our u. So what we get, tan v equal to u, or we can write u equal to tan v. This is the required relation between u and v. This is the complete solution. Very nice solution, very easy. Just practice. Without practice, mathematics is very difficult. With practice, mathematics is nothing. So just taking hard labor, and you will get this type of problem in any semester in B.Tech, B.Tech B, any semester in engineering courses, any semester, either it may be first semester, second semester or third semester, but this will be present. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, please subscribe my channel and click the bell icon. Thank you.